talk about the Earth rotating around itself and then revolving around the sun, the fact that the Earth has a 23-degree tilt, or 23.5, or whatever it is, that is what causes different parts of the Earth, depending on where it is in its revolution around the sun, depending on how the Earth is tilted, one portion, either the northern hemisphere or the southern hemisphere, will be closer to the sun than the other. That happens at 2 times, okay, throughout an actual cycle around the sun. The other 2 times, okay, so when we look at the orbit, let's say, of the Earth, all right, when we look at the actual orbit, we sit here and we see that the orbit goes around the sun as such. Okay, so that's planet Earth's set path. It's like a racetrack and the sun's in the middle of the field. And you can never get off the racetrack. You're in your lane and you can never get out of your lane. Nobody else is ever in your lane. Okay, so one of the things that humans have decided that actually makes a planet is that it has a set orbit and nothing else crosses that orbit on a regular basis. That is one of the reasons that Pluto was demoted from planet status. Okay, because Pluto does not have a set orbit like the rest of the planets do. It actually crisscrosses through Neptune's orbit. Okay? Whether they'll ever come into contact with one another, that's a good question. One would assume that perhaps at some point there will be a collision, but I don't think it's happening anytime soon. Considering that Neptune's year takes 165 years to actually make one go around the sun. Okay? One revolution around the sun. So if we look at this, if we've got planet Earth, okay, and we're going to draw planet Earth in green here. So if I've got planet Earth right here, and planet Earth's axis is at this angle, okay, right here. So that means that our Arctic Circle is up here, our equator is here, and our Antarctic Circle is there, okay? So that means that at this point in its revolution, the southern portion of the actual planet, so this portion here, is actually closer to the sun than up top. And these Arctic circles, okay, the Arctic Circle and the Antarctic Circle actually are decided upon because of the Earth's tilt. When we actually look at the Earth's tilt, we see that the equator for the Earth, okay, runs roughly across the center of the Earth, which is like so. So that's the actual equator, all right? From the actual poles, okay, so from about here up and from about here down, okay, we have our Arctic and our Antarctic Circle. Now, the reason that that is actually demarked, okay, is that in our actual winter, okay, the sun actually stops shining, because remember, the sun goes right through the planet. So the sun actually doesn't reach this top part of our planet up here. These guys in the wintertime are in perpetual darkness. There's no actual, and this doesn't last for very long, but above the Arctic Circle, and Canada actually has communities that live up there, okay, above the Arctic Circle, from let's say November to probably potentially February, there's no light. Okay, they don't actually get daylight because they're so far up, and when the Earth, because of the axis of the Earth, because the bottom part of the Earth, the southern hemisphere, is closer to the sun than the top, that top half does not get any sun. Okay? The same thing happens when this actual planet, when we actually move from here to about here, All right? We're actually the whole half, this whole half of the earth that's facing here, it's all getting equal amounts of sun. The tilt, okay, for 2 parts of this actual revolution, the tilt has no impact on how much sun we're getting. We're getting sun that we would ultimately get regardless. So you ask the question, what would happen if we didn't have an axis, if we didn't have a tilt to the earth? It would always be the actual, weather that we would see, end of September, beginning of March, or end of March sort of deal. Okay, so if we say that this is winter over here, okay, if we say that this is December 21st and that is winter solstice, right? So our days are the shortest that they are. And as we're creeping towards that, our days are getting shorter and shorter and shorter. Now, as we reach that day and we keep on creeping, okay, we keep on revolving around the sun, our days start to get longer and longer and longer. Now, mid-March or end of March, March 21st, 22nd, we reach a point where our daylight, we have as much daylight as we have night. Okay? Because we're halfway through, or we're a quarter of the way through the cycle. Now, when we actually get to the other, okay, when we actually get to the other portion, or the complete opposite here, okay, of our circle, we'll notice that our top half is now closer to the sun, because the equator is like here, okay, and then this bottom half is further away. Now, it just so happens that the northern hemisphere has more land up north than the southern hemisphere does. Okay, the southern hemisphere has basically South America and, Australia, a little bit of Tasmania and Antarctica. And there's nobody really living full-time in Antarctica. Whereas the northern hemisphere, there's many Arctic nations. There are many countries that are bordered by the Arctic Ocean. Canada, okay, the United States for Alaska, Russia, right? All of the northern European countries. Okay, so Norway, Finland, Sweden, Denmark, because Denmark owns Greenland, Iceland. All of these nations, we call them circumpolar nations because they circle, or they're near the northern pole. So they're really affected. Okay, more people get impacted in terms of total nighttime when we're in our winter than when the southern hemisphere is in their winter. Okay, we're getting close to our summer. So we're actually right about, I would say, here on our cycle. Our days are still getting longer. But as of June 21st, we're going to actually be heading towards another equinox here where everybody is the same, right? Where no part of the planet other than the equator is closer to the sun. Okay, the tilt has no bearing here, but it has all the bearing here. So for two of the 4 corners of the revolution, right? It doesn't, the axis has no impact. And those are equinox days, spring and fall. But for 2 of these revolutions, okay, or 2 of these locations, okay, the other complete opposite of one another here, the axis will impact our seasonality big time. Okay, and 23.5 degrees is not a big axial tilt, but it's enough to have us go from, 30 degrees in the summer to minus 15 in the winter. All right, so we are very, very dependent. Like if the axial tilt were ever to change, that would have colossal impacts on our planet. It's not actually going to happen, but that would actually, that would impact our seasonality big time. Okay? So is that clear now on the difference between revolving and rotating. Okay, do we know now how the axial tilt of the planet affects seasonality? Okay, it has everything to do with the degree of the tilt and whether that planet, because of that tilt, that upper portion of the planet is closer or further away from the actual sun. Okay, and so when we're over here, when we're actually over here, all right, we are closer to the sun, and then when we're at the opposite end, the southern hemisphere is closer to the sun. Therefore, it's their summer. So people in Australia, they celebrate Christmas or, Hanukkah or whatever in their summer. Okay, it's always summer for them for Christmas, whereas for us, always winter, right?